Hi, folks. As you can see, we're in Algebra 1 IXL, and I'm going to be looking in section V. This is supposed to be a velociraptor behind me, so it's the V animal. Anyway, we're going to do the power rule. So V.7 is the power rule for exponents. And again, no preview. So yeah, of course. Let's just go ahead and go with the rule. It basically says that if we're going to take a power to a power of a base, we are going to multiply the exponents. And here's the reason this happens. What you see here, if in case you can't see it, I'll write it a little bigger here. This means c to the 8th times c to the 8th times c to the 8th times c to the 8th. And of course, if you have been watching and understanding the exponents, if I multiply 8 c's together and then multiply another 8 c's and another ones and some more, we're really adding those exponents because we're counting how many c's are being multiplied together. Ultimately, that comes down to 8 plus 8 plus 8 plus 8, or better yet, 8 times 4 is c to the 32. And that's the reason we multiply. You want to think about why you do what you do in math, not just how to do it. So there it is. This is c to the 32 power. And we're done. Okay. Now be careful. We may be distributing soon. This one is t to the 24th. Of course, it helps if you know your multiplication tables. And I don't want to spend a lot of time on these easy ones. This is h to the 48th. And oh, here we go. Okay, now we could talk about moving the base and its exponent and changing the sign and yada yada yada, but we are multiplying these together, and the multiplication rules of integers still apply. One way to think of this is that I'm moving it twice. I'm moving it to the denominator because of the -8, and I'm moving it to the numerator because of the -12, and 8 times 12 is 96, yeah. A little slow today. W to the positive 96. A negative times a negative is a positive. So yeah. You got to double check my work there. Okay, this is d to the -3rd. Now, a lot of people are going to say, well, how do you know, sorry, d to the -30. Now, how do you know that it's d to the -30? They don't say that I have to move it to the denominator, but it really is the same as 1 over d to the 30th power, or d to the -30th power. That -3 means it's being moved to the denominator and multiplied 3 times. So if you think about it, it's really 1 over d to the 10th times 1 over d to the 10th times 1 over d to the 10th. And there's 2 ways of looking at it. I assume they're looking for this one since they don't say it has to be a positive exponent. So it's, and I didn't see any fraction, a fraction bar in there. So it looks like that's all they wanted us to do. Now, don't turn your brain off and just multiply, although that will work, -99. And in this one, we've got s to the 66th. At least this one's going to go pretty quickly today. All right. Hopefully we're going to get more than one variable. There we go. Now, oh, wow. Okay, so this is c to the 0, d to the -5, and we're going to multiply that times itself 4 times. C to the 0, d to the -5. C to the 0, d to the -5, and one more time. Now, the 0 multiplication property says that if I multiply the 4 times the 0, I'm going to get the c to the 0 power. And if I multiply the 4 times the -5, I'm going to get d to the -20. Now, there is a distributive property of exponents over exponents, but you need to be very, very careful. Probably one of the most common mistakes in algebra when dealing with exponents is this one. A lot of people will do this. X squared, 2 squared, which gives them x squared minus 4, which is wrong. This is not true. Darn bells. This is x minus 2 times x minus 2, and that gives you x squared minus 4x plus 4. I want you to notice that when you square a binomial, you always end up with a trinomial because that middle term cannot cancel itself out. Now, the reason I'm mentioning this is because this problem is a lot like this one where you have those parentheses, and we'll hopefully make more sense when we get to the other type. C to the 0 is really just 1, just like all of these are 1. 0 plus 0 plus 0 plus 0 is 0. Lots of ways of thinking of it. We just end up with d to the negative 20. The c to the 0 has no value. It's a 1 because we're multiplying it, and it's just the identity of multiplication. Anyway, there it is, d to the negative 20. I think it's better if we do a better example. That one's not my favorite. Let's get a better one here. Okay, d to the 12th. Let's get to a better example. All righty, then there we go. So we are distributing. Now, here's the problem. A lot of people will see this, n to the 6th, p to the 10th, which are being multiplied together, and we're going to multiply that 3 times. And so we can distribute this exponent over the 2 parts. And of course, we get p to the 30th, that's the 30th, and n to the 18th. That's our answer. Now, the problem is that that is not the same thing as this. This is actually going to be a big polynomial. It's going to have, it's probably going to have, let me see, how many terms is it going to have? It's to the 3rd power. So it's actually going to have 4 terms altogether. And it's going to be a major problem. You cannot distribute that 3 to those exponents because it's over addition, not over multiplication. So just be careful. N raised to the 18th. I want to go into the details, and I know I can't, just don't have the time, and you all aren't interested in the details. You just want to know how to do it. So there we go. Okay, so this one is going to be j to the 10th, k to the 24th. J to the 10th, k to the 24th. Oh, darn it. Be careful, don't do that. K to the 24th. Make sure that you're on the same line. Let me just double check it. Yeah, there it is. We distribute the exponent. If we're talking about multiplication or division, division also works. If you had, for example, j to the 5th divided by k to the 12th, that raised to the 2nd power. We could distribute the 2 to both parts. And of course, we would get j to the 10th, over k to the 24th. So it works for division and multiplication, but not addition and subtraction. So there you go. All right, let's see here. We're almost done. It won't take long now. So I'm just going to go ahead and write down the answer. Q raised 6 times negative 9 is negative 54. And then I need the r raised to the negative 48. And we're done. There we go. And we get an r raised. This says r to the 7th, and it's going to be raised to the negative 35. I'm just multiplying my exponents. And we have an s raised to the 30th power because I've got a negative 6 times a negative 5, just in case you can't see it there. I'll write it bigger next time. Okay, so we've got u to the 5th. Darn it. There we go. V to the negative 10 raised to the negative 2 power, and we end up with u to the negative 10, v to the 20th power. And of course, we could move that u to the denominator or not. It doesn't make any difference. In this case, they just wanted us to use the negative exponents. V raised to the 20th power. Double check my answer, looks good. Okay, that is t to the negative 100. That is j to the 24th. Gotta get down in there. There we go. K raised to the negative 48. Yep. Okay, 3 of them. We have u, I'll write it out here so you can see it. U to the 8th, since it's a little different than the others. V to the 8th, W to the negative 2, all raised to the negative 4 power. This is all multiplication, so I can distribute the exponent. So we end up with u raised to the negative 32, v raised to the negative 32, and w raised to the positive 8. I'm just multiplying exponents. Remember, rules of integers still apply. Okay, so that's going to be x to the 144th power. That y to the 0 is times 12. The 0 times 12 is still 0, and y to the 0 really is just 1. So when you talk about y to the 0 being 1, notice that it is the right answer. 12 times 12 is 144. Okay, this one's going to be d to the positive 63, because I've got 9 times 7, both of them negative, and a g raised to the negative 49, and positive 7 times a negative 7. And looks like we're getting there. Okay, u to the negative 8, and a v to the negative 40. Probably don't need to go all the way, but I'm going to go ahead and finish it. Might as well, since I'm almost there. Oh man, one at a time, really? Maybe not. S to the 21, t to the 15, u to the 33. Looks good. Distributing that exponent over those, over that multiplication. By the way, this is sometimes called the distributive property of powers over multiplication, just like this. I should make it similar, huh? Well, it's sort of similar. This is called the distributive property of multiplication over addition. The one we're doing is the distributive property of powers over multiplication. So we're distributing these powers over that multiplication that we see there, over that product. X to the 7th, y to the 28th. Oh man, come on. Y to the 28th. Hopefully that space doesn't give me a problem. Z raised to the 21st. Let's just check it real quick here. Does it look good? And it does. Notice that I have a negative times a negative, and a negative times a negative, and a negative times a negative. Probably should have put negatives on here as well, but oh well. So it's a similar situation, but be careful. You cannot distribute exponents over addition. No, don't do that. What not to do. All right, we got, s to the negative 24. I'm gonna get rid of this guy. S raised to the negative 120. T raised to the positive 36. Just have to make sure you multiply correctly and move your bases down where they belong. This is positive 120. Double check it. Easy to make mistakes there, but it's okay. I'm sure it's right. I'm going to insist on going all the way. So it's h to the 60th. Yep. J to the 48. and k to the 84, I believe. Oh, raised to the 84 would be good. Yeah, 12 times 7 is 84, 12 times 4 is 48, 12 times the 5 is 60, and my bases are right. 4 more. Okay. T to the negative 20. The u to the 0, remember, is just 1, so I'm just going to ignore it. V raised to the negative 60. It's probably, it may not count it wrong if you put the u to the 0, but you really should get rid of it, at the time. Looks good. 3 more. So b to the negative 8. C to the negative 36. And d to the 40th. I guess 15 minutes isn't so bad. P raised to the 7 and Q. I could put the 1 or not. It's completely up to you. And looks like we have one last one, finally. Okay, so we've got V to the 120th power. They want to make one more stab at the 0 power. And we are done. And I hope you guys will go to mastery as well. There it is. We're all finished. And I will see you back in the next section. Bye, everybody.